Hello guys, so I'm back once again in this documentation reading series. So we were going through Matplotlib documentation, the introductory section, and we had done up till this pyplot tutorial, and we had to start sample plots in Matplotlib. I'll just like to point out one thing in case someone is wondering. In the last session, while we were discussing, if you've seen that, we noticed this typo. There were with twice. So I had in fact gone and made this change in this open source in the Matplotlib library. So I fixed the grammar error and it was accepted. So like I had mentioned, I have done the contribution now. So now back to business. Yeah, and so each and every plot here has an intensive documentation alongside it. So when you click on plot, you'll see that it's like a very long documentation, and going through all of them is not going to be my main aim here. I'm just going to get a brief idea of what every one of them is. So let's have a look. Line plot. So here's how to create a line plot with text labels using plot. Plot y versus x as lines and or markers. Okay, the call signatures, plot xy, fmt, this and that, all of this stuff. The coordinates of the points or line nodes are given by x comma y, which is uh, obvious if you studied Cartesian geometry, the Cartesian coordinate system. The optional parameter fmt is a convenient way for defining basic formatting. I guess fmt is short for formatting, like color, marker, and line style. It's a shortcut string notation described in the notes section below. Okay, so first of all, let's just copy this and paste them here. And yeah, this will not run. Can you spot why? Because the functions I've copied with are just plot, while I need to use plt.plot instead. So I'll change this right here and just copy this change everywhere. So here, 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 and here. And now when we run it, I'm getting the issue. X and Y must have the same first dimensions but have shapes 100 and this. Okay, so the problem now here is that X and Y are not, these were just examples of X and Y. We don't have any created, um, like anything created for X and Y. So I'm going to create a random array np.random dot rand int, and I'm going to take 100 of them. Then y is also going to be np.random.rand n in this case, and 100 of those. And now when we try to plot them, what is the error again? X and y must have the same first dimension but have shapes 1 and 100. What went wrong now? Does doing this make any difference? Okay, so okay, I just gave them the range. I've not given them, like, so between 1 to 100 I need 10 values, and for this as well I need 10 values between 1 to 100. So yeah, now you can see they're plotting x and y, one with blue color and circular O like markers, and one with y plotted with red color and plus markers. I'll just print out x and y as well so you can have a look at them as well. I need to split this cell here. Okay, I'll just cut this stuff, insert cell below, two of them. So first x, and then we have y, and then we have this. So that makes sense now, I think. We can use line 2D properties as keywords arguments for more control on the appearance. Line properties and format can be mixed. The following two calls yield identical results. Okay, so yeah, I'll just copy this again, doing the same plt.plot. You might be wondering what happens if I use matplotlib.pyplot.plot. It will not work because now you've used an alias for it. Um, yeah. So these are exactly the same. So you won't be able to make out any difference, but if you plot them side and look at them, they are exactly the same things. So what happened is this was green and marker was O and the line style was dashed. So you've mentioned them explicitly here, but you've combined them into one code here. So now going ahead, plotting label data. There's a convenient way for plotting objects with label data. That is data that can be accessed by index object y instead of giving the data in x and y. You can provide the object in the data parameter and just give the labels for x and y. Okay, let's just try it. So I need to give some data, right, about giving x. Okay, it should be plt.plot. I'll still get the error. Unrecognized character 1 in format string. I guess it has something to do with data, but if I just do this, this should have worked, right? Because the x label and the y label, unrecognized character 1 in format string. Does this do anything? How about data equals object? Still, I'm getting object not defined. How about I just pass a list myself? No, that won't work. How about x? Won't work again. How about a list with x and y? Still won't budge. So unrecognized character %c in format string. I'm not able to figure out what's going on right now, but we'll hopefully be able to figure it out by the end of the video or in another video. All indexable objects are supported. This could be a dict or a pandas data frame or a structured numpy array. Rx was a numpy array, right? How about we create a data frame and try to use that? We must have created a data frame in this video at least once. Yep. So let's use this A. First of all, let's print out A. Let's try using A. Will it work? Still getting an error. Unrecognized character. Um, does it need to be something like this? I'm not sure. I'm just trying out my luck. No. So it seems something is going wrong. Plotting multiple sets of data. There are ways you can just call plot multiple times. Alternatively, if your data is already a 2D array, you can directly pass it to x and y. A separate data set will be drawn for every column. Example, an array A where the first column represents the x value and the other columns are the y columns. Okay, we have A, but I'm not sure if this will work. So plt.plot. Yeah, I'm getting these errors and I'm not able to understand why. But I guess it has something to do with the things I'm using. It was for a 2D array, but I can't figure out why. So let's just read the documentation further. The third way is to specify multiple sets of X, Y, and format groups. Okay, so this is one and this is another. Okay, this should work because we have used, but I won't be making any promises now considering what has happened so far. So let's plot X and Y and X. Yeah, so we got a plot for X and Y and another for Y and X. In any case, any additional keyword arguments applies to all datasets. Also, the syntax cannot be combined with the data parameter. Okay. By default, each line is assigned a different style specified by a style cycle. The format and the line property parameters are only necessary if you want explicit deviation. Alternatively, you can change the style cycle using RC params. Okay. Now let's have a look at the parameters x and y, array like or scalar, a horizontal vertical coordinate of the data points. X values are optional and default to range of length of y. Okay, commonly these parameters are 1D arrays. They can be scalars or 2D. The arguments cannot be passed as keywords. FMT is format string. Arrow for red circles. You can see the notes section for a full description of the format strings, but there is no access to the notes section. It will be helpful if they can add something like this. So maybe I'll just copy this and keep this in store for some change later. So I'll just mark down this and insert cell below. Yep. Format string are just an abbreviation for quickly setting basic line properties. All of these and more can be controlled by keyword arguments. Okay, the argument cannot be passed as keyword. Okay. Data, indexable object optional. An object with label data, if given, provide the label name to plot in X and Y. Technically, there's a slight ambiguity in calls where the second label is a valid format. Dot plot no data object could be plot xy or plot y comma format. In such cases, the format interpretation is chosen, but a warning is issued. You may suppress the warning by adding an empty format string plot. Okay. Returns a list of lines representing the plotted data, and then there are all of these arguments. Okay, so the nodes were right here, down here. Yep. So we had a look at this. Now let's look at multiple subplots in one figure. We also have had experience with this in previous videos. Add a subplot to the current figure. Wrapper of this with the difference in behavior explained in the node section. Call signatures are these: number of rows, number of columns, index, keyword arguments. POS is position, then keyword argument, directly keyword arguments or X. Okay. Now let's have a look at the parameters. Arguments. 3 integers, n rows, n calls index. The subplot will take the index position on a grid with n rows and rows and n calls columns. Index starts at 1 in the upper left corner and decreases to the right. Index can also be two tuples specifying the first last indices, one based on including last of the subplot. Example figure add plot 3112 makes a subplot that spans the upper two-thirds of the figure. Okay. A 3-digit integer. The integers are interpreted as if separately given as 3 single-digit integers, that is 235 is like 2 rows, 3 columns, and index 5. Note that this can also be used if there are no more than only be used. Okay, and a subplot spec. What is this? Hmm. Specifies the location of a subplot in a grid spec. Okay, so like we had used, I guess, like the 311 and stuff. Now projection. The projection type of the subplot. Okay, STR is the name of the custom projection. The default none results in a rectilinear projection. Okay, polar. If true, equivalent to projection is equal to polar. Okay, share x, share y, share the x or y axis with share x and or share y. The axis will have the same limits, sticks, and scale as that of the shared axis. Okay, label a label for the returned axis. Returns. The axis of the subplot, the returned axis base class depends on the projection used. Okay, it is axis if rectilinear is used, and this if polar projection is used. The returned axis is then a subplot subclass of the base class. Okay, so are there any examples which we can try out? Yeah, let's do this. We've plotted this, and now we are going to create a subplot. So what this basically did was plot a line implicitly by creating a subplot. Now create a subplot which represents the top plot of a grid with 2 rows and 1 column. So 2 rows and 1 column. Since the subplot will overlap the first, the plot and its axis previously created will be removed. So if you run all of this in the same line, you'll see first this was run, but since this was run, so all of this stuff was then removed because it overrode sort of. If you do not want this, use this method or the pyplot access function. In the figure already had a subplot, then it will make that subplot current and return it. This behavior is deprecated, while if you do not want this behavior, you must use a unique set of arguments and keyword arguments. Okay, this stuff is getting very complicated very quickly, and I'm not able to follow along in some parts. And as far as I know, in your general purpose use, you won't be needing like every nitty gritty. And if you ever need something, you can always look that up. So maybe you want to, say for instance, look at the grade and stuff. You can always come to the documentation and look at them. There's no need to memorize everything, but as you practice, you'll learn stuff. So if we use this, we created this subplot. This is also equivalent as we had seen. This creates a subplot but with no frame. So let's just run them on distinct lines, right? So it will be more easy to follow along. So first of all, let's run this. Created a subplot. Now this is same but more general. Yep. Now let's have a look at this. Now we have no frame as frame on is false. How about this? If we have a look at this now, you can see this is a subplot and it's a polar projection. Now if we have this, it was going to share the axis and the face color is red. You can delete axis too, I guess, and you can also add axis to the subplot again, so it's up to you. But right now the subplot, there was no subplot which we were referencing in this line, so nothing really happened. It raised the error in fact. So now let's have a look at oh, it's quite long. Probably we won't even be able to cover everything. How long is the video already? It's 17 minutes. Let's try to cover some more. But now we won't be going so much in depth. So images, Matplotlib can display images assuming equally spaced horizontal dimensions using the imshow function. Yeah, this is something which I wanted to show you guys. So display data as an image that is on a 2D regular raster, and the input may either be an actual RGBA data or a 2D scalar data which will be rendered to a pseudo color image. For displaying a grayscale image, you can use this mapping function and stuff. And for this to for actually using this, I'll have to prepare an image and then use it, but I'll just show the parameters. MNN, MN3 will an image with RGB value, MN4 an image with RGBA value including transparency. These are the supported array shapes. Out of range will are clipped, and then all of this is not really important right now, so I'm not going to go in depth in all of these things. You can, if you want to, go ahead and read all of this stuff. Now contouring and pseudo color. The p color mesh function can make a colored representation of a 2D array. Even if the horizontal dimensions are unevenly spaced, the contour function is another way to represent the same data. Example, comparing contour mesh and p-color mesh. Oh, sorry, p-color mesh and contour. So let's have a look at them. P-color mesh creates a pseudo color plot with a non-regular rectangular grid, and this plots contours. So what are contours? An outline representing or bounding the shape or form of something. Okay. Contour and contour F draw contour lines and filled contours respectively, except as noted function signatures and return value are the same for both versions. They have the parameters, the levels, and returns a quad contour set. Parameters, you can easily see the height, the length, the width and stuff. Let's look at levels. Determines the number and position of the contour line or regions. If an int n, use max n locator which tries to automatically choose no more than n plus 1 nice contour levels using vmin and vmax. If array like draw contour lines at the specified levels, the values must be in increasing order. Okay, there are lots of parameters here, and um, we don't really get to know what vmin and vmax are here. Vmin in matplotlib. Vmin and vmax in imshow are used in conjunction with norm to normalize your data. You get a plot like this. Okay, so these are used to normalize the data and to its minimum. Okay, so im should normalize the data while we set vmin and vmax to 0, and one the colors will be normalized as if there was a value 0 and a value 1 present in the data. Okay, other than that, I'm not going to read all of this. We're just going to go ahead. Now let's have a look at histograms. Plot a histogram, compute and draw the histogram of x. The return value is a tuple if the input contains multiple data, or this if the multiple data can be provided by x as a list of data sets or potentially different lengths, or as a 2D array in which each column is a data set. Note that the ND array and dimensional array form is transposed relative to the list form. Masked arrays are not supported. X input values that take either a single array or sequence of array which are not required to be of same length. Okay, bins. If bins is an integer, it defines a number of equal width bins in the range. If bins is a sequence, it defines the bins edges, including the left edge of the first bin and the right edge of the last bin. If the bin, in this case, bins may be unequally spaced all, but the last rightmost bin is half opened. In other words, if bins is this, then the first bin is this, including 1 excluding 2 this, and the last bin is this which includes 4. Okay, if bins is a string, this one of the binning strategies supported by this, auto, empty, domain, all of this. We can set the range, the density, the weights, the cumulative and all of this stuff. Are there any examples? None. So let's try to use this. How about plt.hist and x? Yep, plt.hist. Y, and how about now using plt.hist x comma y? Yeah, so we are getting histograms. I'm not going to look what exactly is happening from a mathematical perspective. You can look that up yourself if you're interested in that part. uh, how about paths? You can add arbitrary paths in matplotlib using the matplotlib.path module, a module with for dealing with polylines used throughout Matplotlib. The primary case for polylines in Matplotlib is path. Almost all vectors drawing makes use of paths somewhere in the drawing pipeline. Whilst the path instance itself cannot be drawn, some artist subclasses such as path patch and path collection can be used for convenient path visualization. Okay. This seems quite complex right now. I'm not going to read the entire documentation, but you can, if you feel like you might be needing to draw such vector paths. Now we're getting into more advanced territory as we pass. So 3D plotting, you can use the mplot 3D toolkit. It has support for simple 3D graphs including surface, wireframe, scatter and bar charts. We have to thank these guys: John Potter, Jonathan Taylor, Rainer Hayes, and Ben Root. I probably mispronounced their names, but thank you guys. This toolkit is included with all standard Matplotlib installs. Streamplot plots vector fields. If you have seen 3 blue 1 brown videos, uses another uh, library called manim, but it is also he often uses such vector field drawings. Eclipses in support for Phoenix mission to Mars, which uses Matplotlib to display ground tracking of spacecraft. Michael Drott Boom built on work by Charlie Moore to provide an extremely accurate 8 spline approximation to elliptical arcs, which are insensitive to zoom level. I'm not sure what that means, but sounded cool. Now let's have a look at bar charts, and these are probably things which you use more than often if you're doing data analysis. So bar charts creates a bar plot, and let's just use it. Bar in x, comma y. So x, the x coordinates of the bar, height, the heights of the bars. So for each x, you've given how tall they are going to be. So if I were to like print insert cell below, insert another cell below. So here we have x, here we have y. So first of all, this value seems a bit less than 30. So a bit less than 30, this is 29, and correspondingly the height we said was 72. So you can see it is somewhere around 72, between 60 and 80 we have 70, and a bit higher we have 72. So you get the idea how it's plotting. Then again it has all of these things, the align, the bottom, the width, and you can tinker around with all of these and read more about them. Now let's have a look at pie chart. The pie function allows you to create pie charts. Optional features include auto labeling the percentage of area, exploding one or more wedges. Okay. So again, let's just use plt dot pie, and how about adding x? So yeah, it plotted x comma y. So probably it gave it's taking its time. What happened? I can't understand really what happened here, but seems something broke, or it's printing in some form which I'm not able to interpret. Maybe Y is acting in some other fashion, not like I'd expected. But here you get the idea how it's plotting X. You might be wondering how it's getting what percentage it's take. The fractional area of each wedge is given by x upon the total sum. If the sum is less than 1, the value of x give the fractional area directly, and the area array will not be normalized. The resulting pie will have an empty wedge of size 1 minus sum of x. Yep, colors and stuff you can change. Now let's go ahead and look at tables. The table functions add a text table to an axis. Or like you've probably used MS Excel and plotted graphs, and you can add a data table. It does something like that. Scatter plots make a scatter plot, as the name suggests. The example plot changes in Google stock price with marker size, reflecting the trading volume. So let's just try it. Plt.scatter, and let's have a look at x. Yeah, it needs two variables to plot against each other. So like again we have 29 and 72, 31 and the smaller value. So corresponding 31 we had 3, so it is now you get the idea how it's plotting. You can again have so many parameters, so many things, but I'm not going to go into everything. Now GUI widgets. Matplotlib has basic GUI widgets that are independent of the graphical user interface you are using, allowing you to write cross GUI figures and widgets. So you can have a look at them if you are working with graphical user interface. How about filled curves? The fill function lets you plot filled curves and polygons. So this is probably a fractal if I'm not wrong, but I could be totally wrong. So dot fill, each polygon is defined by x list of x and y. So plt dot fill. How about something went wrong? X comma y. Yeah, it's doing something like this. So we have again those values and it's forming some sort of shapes with them. Data handling, you can plot time series data with major and minor ticks, and we'll have a look at these probably in the future. You can use the log plots, the semi-log and log functions, simplify the creation of logarithmic plots. Polar plots are the used by the polar function. These are polar plots. Legends, these are the legends. They automatically generate figure legends with MATLAB compatible legend placement function. Text notation for text. So this is now going into latex territory. Native text rendering, although Matplotlib internal mat rendering engine is quite powerful, sometimes you need text. Matplotlib supports external text rendering. EEG GUI, you can embed Matplotlib. This is a screenshot of EEG viewer called pbrain. So probably it's some medical stuff. I'm not sure what EEG is. Let's look it up. EEG, okay, electroencephalogram. This is probably used in medical fields. And now we have our favorite XKCD. XKCD, if you're not familiar with, is uh, internet legend who creates all these things, all these cartoons, comics probably. And here you can create plotting in XKCD style. You can create subplots like these, and like they've shown the example. So let's just use it. So first of all, they took random.seed. I'm not sure what that means. This the seed function is used to initialize the random number generator, and it needs a seed value. Okay, so it's something like it's doing generating random numbers. And have I gone into the wrong file? No. And yeah, that's it. So what this did was then again take some random values and then plot them using hist, scatter, plot, and hist 2D, and then show them all. So thank you guys. This video was quite long, possibly boring even. Some parts certainly went over my head. And to be fair, you don't need to understand everything in this documentation, because if you did, probably I guess no one does except the people who made it, because you really don't need to use everything. So in the next few videos, I'll probably do this image tutorial, the life cycle of a plot, and then this, and then probably put this on hold for a while. So thank you guys for watching, and see you again next time.